Welcome back everyone. In today's session we are going to see question number 5 and 6 of exercise 14.4.3. Sorry. In the previous sessions we have seen question number 2, 3 and 4. Now let's see question number 5. So before we go for question number 5, let's understand a concept. First, let's understand the question. From the choices given below, choose the equation whose graphs are given. So you can see one graph is given for figure 4.6. This is figure 4.6 and 4 equations are given for it. So we have learned graphs in our previous sessions. So for each equation we get one line. Okay, so this graph which you can see, the line is drawn for any one of these 4 equations, but we don't know which equation it is drawn for. Okay, and this 4.7 graph is drawn for any one of these equations, but we have to find out for which equation this graph is drawn. Now we have to do the reverse procedure. Okay, in previous sessions we have done question number 1, for which we found solutions. Remember, we found 2 solutions of each and we drew the graph. But now here it is opposite, exactly opposite. Here graph is given and he is asking for which equation it is drawn. Okay, for which equation the graph is drawn from these. And here also the graph is given and he is asking for which one of these the graph is drawn. So it's quite different. I can say exactly opposite to what we did in the question number 1. So this is very simple. Let me explain you one concept before we go for it. So you can see one equation here at the top, that is x plus 2y is equals to 6, and some solutions are found. Okay, we found some solutions because this has infinite solutions, so some solutions are found here. X and y, you can see the tabular form, x and y, these are the solutions of these equations. Okay, and taking these solutions, a graph is plotted here. You can see this is the graph plotted. So you can see 0, 3 is here, and this, what is the second point? Second point is 2, 2, it's here. Third is 4, 1, and fourth is 6, 0, so on. Okay, it goes on. This is a never ending. Okay, this line is never ending. This can be extended indefinitely in both the directions. So solutions are also never ending. That's the reason we say this has infinite solutions. Okay, now if you substitute, so suppose along with this equation some more equations are given and the graph is given. Okay, some more equations are given and graph is given. This graph is given along with this equation and some more equations. So now you want to check for which equation the graph is drawn. It's very simple. For every point whose coordinates satisfy this equation, it lies on the line AB. You can see some points here. These are the 3 important points which you have to go through. Every point a comma b on the line AB gives a solution, and any point which does not lie on the line AB is not a solution. So every point on this line will be a solution of this equation. So I can say all these points are solutions of this equation. So what do you mean by solution? How do you check it's a solution or not? Just you substitute 0, 3 in place of x and y. Okay, which you know very well. 0, 3 is 0 plus 2 into 3 is equals to 6. 0 plus 6 is equals to 6. So it satisfies 0, 3 satisfies our equation. So like this you have to check for other points also. 2, 2. So if you substitute 2, 2, the second point. So 2 plus 2 into 2 is equals to 6. 2 plus 4 is equals to 6, and 6 is equals to 6. So if it is a solution, you always get equal answer like this. 6 is equals to 6 in all cases. If it is not a solution, so 4 comma 1 also you have to check. Same thing, 4 plus 2 into 1, 6, and 6 comma 0 also you check. 6 plus 2 into 0, that is 6 plus 0 is equals to 6, so 6 is equals to 6. So all these are solutions. So we can say that this graph is drawn for this equation. Okay, so every point on the graph, this is very important point, every point on the line will be a solution of the equation. Okay, every point on the line will be a solution of the equation for which the graph is drawn. If you takes any other value of your own, okay, it may not be solution of that. So this way we have to substitute in each equation and check. Okay, here you can see there are solutions, so we'll check now. We'll take the first question. So here there are 3 points, minus 1 comma 1, 0 comma 0, and 1 comma minus 1. So we have to check these three are solutions of which of the following equations. Okay, these all three will be solutions of any one of the equation. So we'll proceed now. Minus 1 comma 1, these are our points I have taken. Minus 1 comma 1, 0 comma 0, 1 comma minus 1. So we'll substitute one by one. In the first equation I am substituting y is equals to x. Okay, y is equals to x. So what is x and y in our minus 1 comma 1? X is minus 1 and y is 1. So if you put it like this, y is equals to minus 1. So is y is equals to minus 1, y is 1 and x is minus 1. So are they equal? They are not equal, isn't it? So it does not satisfy. You can say it does not satisfy. Then go for the next. If it does not satisfy for one, you should not go for the other. Okay, no need to go for the other, because first one itself is not a solution. Okay, so every point should be a solution of that equation. Okay, every point must satisfy the equation. Let's go for the second equation now. X plus y. So what is our first point? Minus 1 plus y. So minus 1 plus y is equals to 0, y is equals to 1. So I have got y is equals to 1. If I substitute x is equals to 1, I have got y is equals to 1. It satisfies. If I substitute x is equals to 0, I am getting y equals to 0. If I put x is equals to 1, I am getting y is equals to minus 1. So this satisfies. Okay, all the points satisfies here for this second equation. So we can say now there is no need for you to go for the other, because we have got our equation. So once you get your required equation for the graph, there is no need for you to go for the other. There is no need to try this. Okay, so x plus y equals to 0 is the equation for which the graph is drawn. Same thing you have to do in this also. You should substitute each point in each equation and check for which equation this graph is drawn. So we are substituting in first and it does not satisfy. We are substituting in second, that too doesn't satisfy. Then we are substituting in third, the third equation satisfies. Okay, so all these points are solutions of the third equation, y is equal to minus x plus 2. So our equation is minus x plus 2, y is equals to minus x plus 2 is the required equation for which the graph is drawn. Okay, Hope you are clear with this concept. Now let's go to the other bit, the question number 6. In physics you might have learned the formula for work done. Yes, work done is F into S, force into displacement. Okay, so this question is based on that. If the work done, so let's see this question. If the work done by a body on application of constant force is directly proportional to the distance traveled, we have to express this in the form of linear equations in two variables and draw the graph of the same by taking the constant force as 5. So we'll begin in this way. We'll let the distance traveled be x and work done by the body be y. Y is equal to kx. Okay, work done, the formula is W is equal to F into S. You can write W is equals to F into S also. Okay, so here what is the constant? Instead of writing y is equals to ky kx, you can write W is equal to F into S. So here the constant force is how much? 5 units. So W is equals to, you can write 5s. This is our linear equation in two variables, that is W and S. Okay, so you can see in the question the constant force applied is 5 units. Okay, after finding the equation, you can either write W is equal to 5s or you can write y is equals to kx. Both are correct. Here force is taken as k, work is taken as y, and distance traveled is taken as x. Both are correct. Okay, if you are confused with x and y, you can go with W, F and S. Now we need to draw the graph of this. So we'll find two solutions. We'll take distance traveled, that is x is equals to 0 or S is equals to 0. So we get y is equals to 0 or W equals to 0. And if you take x is equals to 1, that is S is equals to 1, you get y is equal to 5. So we'll find two solutions of this and we plot the graph for it. Okay, 0, 0 and 1, 5 comes here. Okay, and after plotting the points, we join the line and we get the graph of this. Also read from the graph the work done when the distance traveled by the body is 2 units. So when the distance traveled by the body is 2 units, no need to draw the graph. From the same graph you can, once you can draw the graph, from the same graph you can take for the distance traveled by the body is 2 units, what is the work done. So you can just drop a perpendicular here and it is 10 units. So when the distance traveled by the body is 2, the work done is 10 units. Okay, you can even substitute in W is equal to F into S. You have that option too. Hope this concept is clear.